Okay, hello everyone. People have said that they've struggled with question 3 from today's work, so I'm just going to put a 3-part B, so I'm just going to go through it in a little bit more detail. Thanks to Alex's instruction from a while ago, I've slowed my mouse speed right down, so I should have more control over it, slowed it a bit, but now I should have even better handwriting. Okay. A particle P moves along a straight line in which in such a way that at time t its velocity is given by this. Okay. The times when P is at rest is, hopefully we're able to work that out, was t equals 2 and t equals 4. That bit we seem to be reasonably confident with. The total distance travelled by P between t equals 0 and t equals 4. Now, what people are going to be inclined to do is this. They're going to integrate, which is what you do, but integrate this expression here. I won't even draw it because I don't want us to think that this is what we should do. Integrate this between 0 and 4. If you integrate it between 0 and 4, that will give me the displacement over that time. But I don't want the displacement, I want a distance. Distance is a linear quantity, if we remember. What's basically happening, is that between the times of 0 and 2, this particle is moving, so it covers a distance. Then between 2 and 4, let's just say, for instance, it moves like this. Then between 2 and 4, it moves again, yeah? But it might move over here or something. So the displacement will be affected, but the distance is literally this value, add this value. That's why whenever it talks about these things, they normally set it up really nicely. Find the times when it's at rest, and then treat those as 2 separate journeys. Or if there'd been 3 points where it was at rest, you'd treat it as 3 separate journeys. So if we have this, the first thing I'm going to do, I was in 2 minds whether I was going to show you this, but I will show you this because it is very important to what's going on. In the event that we drew a graph, guys, if we drew this, I'll just draw quite a rubbish graph over here to show what this would look like. So if I drew a graph of velocity versus time. So I know that it's going to have a y-intercept of 4. I'm basically just going to sketch this graph. If I made v equal to 0 and then solve to find t, I'll get t equals 2 and t equals 4. So this is what my graph will look like. If we remember, if we integrate, the area underneath a velocity time graph is going to be the distance. So if I think about it, between t equals 0 and t equals 2, I'm going to get one distance here. And then between t equals 2 and t equals 4, I'm going to get this distance here. Then I'm going to sum those two values together. Right. The total distance travelled by P between those. So first thing I'm going to do is, if we remember, I integrate my expression for velocity with respect to time. So I'm going to integrate a half t squared minus 3t. God, this has improved my handwriting actually. I should have slowed it this far down a while ago. Apologies, Alex, for not doing so sooner. Okay, so if I integrate that, that's going to give me my expression for displacement. So if I simplify that, I'm going to get increase the indice by 1 divided by the new indice is going to give me t cubed over 6 plus 3t squared. Sorry, minus 3t squared. Oh, it's moving so slowly now, it takes me ages to get there. Minus 3t squared over 2 plus 4t plus c. Right, if I think about it, for the sake of this, I'm going to say that at the beginning, because I'm working out the displacement for this part of the journey, I know right at the beginning, obviously t equals 0. And I'm going to say that it has moved no distance at that point. So right at the beginning, t equals 0 and s equals 0. So if I were to put t equals 0 and s equals 0 into this, that would result in, therefore, c equals 0. I now have my expression for the displacement, which will be s equals t cubed over 6 minus 3t squared over 2 plus 4t. Right. As we discussed, I need to treat this as two separate journeys, then add the total distance that it is covered. For the first part of the journey, I'm looking between 0 to 2 seconds. Well, I've already integrated my expression here. So I'm going to have t cubed over 6 minus 3t squared over 2 plus 4t. And what I could then do is do that between 2 and 0. So if I have that, I know that if I plugged in 2, then plugged in 0, well 0 is pretty easy because that would just make all of that. So it's basically the value when t equals 2, that's going to give me 10 thirds. Then I'm going to work out the displacement between 2 and 4 seconds. Always look at the displacement, split these journeys up between when the particle is instantaneously at rest. Yeah, so when it is at rest, so say as I've said then, between 0 and 2 it's at rest. Then there'll be a journey between 2 and 4, then it will be at rest. Always treat those as separate journeys. So again, we've got, take a cheeky shortcut here. I've already integrated it, but this time it's going to be between 4 and 2. Now, when I put this in, it actually gives me minus 2 thirds. Because that's a displacement, remember. This is telling me it's gone forward 10 thirds, then maybe back 2 thirds. Yeah, and the reason, in fact, there's negative 2 thirds as well is because if we look at our diagram, we can see that it was underneath, wasn't it? But if we remember, we don't care about direction when it comes to distance. This is the displacement. The distance, therefore, is therefore 2 thirds. Whatever that value is, I'm going to make it positive because it's moved 2 thirds. Therefore, if it's moved 10 thirds, this much, and 2 thirds this much, is going to give me 12 thirds. 12 thirds is the same as 4. Therefore, it is moved 4. Yeah, 4 units, I should say.